Hey everyone, my name is Anvita Bansal and we are back with another lecture based on LinkedList. So the problem that we are going to discuss today is, I'll just quickly show you, reverse a linked list in groups of given size. Let me just, so we are live, that's okay. Just pause it so that voice doesn't. Okay, so reverse a linked list in groups of given size. The question is, that you will be given a linked list. Okay, so we have already solved question in which we have reversed linked list. Now you know how to reverse a linked list. The variation of this problem is that you have to reverse it in some groups of given size. For example, if k is equal to 4, so what can you observe here is, first you are reversing the first 4 nodes in the linked list, right? Then it is getting connected to the another next 4 nodes of the linked list, and that also in reverse order. So when you reverse this first 4 nodes of linked list, what you should ideally get, the head should become 4, then 2 2 1, 4 2 2 1, and then it has to get connected to the another 4 linked nodes of the linked list that are themselves reversed. So if I consider each 4 nodes of the linked list, group of 4 nodes of linked list as different linked list, and let's understand it in this way, that we are reversing them, then what we will have to adjust is how we are pointing, keeping the track of the new tail which is connecting to the new head of the reversed linked list. So if I reverse the next half of this linked list, which is k equal to 4, I should be getting 8. For this new linked list, the new head must be 8 and the tail should be 5. So let's see and understand what can we do. So the code seems simple here, because what approach we have written in this code is recursive approach. So this question, first of all, you need to understand the intuition, which is not difficult. The intuition is very simple behind this question, which is 1 connecting to 2 connecting to, for example, I'm just taking this example, let's say 5 6 7 8. Got it? Okay, now if I tell you your k is equal to 3, that means you will have to reverse groups of 3 nodes in the linked list. So ideally what it should look like, I'm sure you must have understood by now. So it should be 3 to 1, like this, 3 connecting to 2 connecting to 1. Now this one should be not, it shouldn't be directly pointing to 4. No, the next 3 nodes should also be reversed. So the next new head of this group of linked list will be 6. And if I see it in reverse order, it should be 5, then 4. Got it? And now I get, what I get is 7 8. So since I see that k is equal, k was 3 and the nodes I'm left with is 2, so 2 is less than 3. So remaining nodes also, if obviously I'm getting remaining nodes less than k, I should reverse them. So the new head for this will become, reversed list will become 8. So this 4 should be pointing to 8. This is the intuition behind this problem. Now how can we do it? So we have to basically, so here you see, the first reason is that we have used recursive approaches. You see repetition of sub problem, right? So we are repeating the same process on groups of linked list of size k, right? So let's reverse the linked list of size k and ask recursion to do the same for the remaining nodes of the same size in the linked list. Got it? And then what we will have to do is, we will have to track what is our new head, our new tail, so that we can point to the reversed head of the next group of the linked list. Okay, so let's see how can we do that. Let's take few pointers here. So the node, we are going to take node current, we have previous node, we have, let's take next node, and what else we might need, let's see. And current, right now I'm pointing to the head of the given linked list, it is pointing to head. Previous right now will be pointing to null. Next also let's point it to null. And see, what we have to do here is, we are taking these pointers, previous, next and current, in which I have pointed current to the first node of the linked list, head of your linked list. Okay, so as you see here, this is the given function of your list. Now what I'm going to do, I am taking 3 pointers in this list and also taking a count. Now let's see what are we going to see here, what are we going to do here. So focus on one only linked list of size 3, the first 3 nodes of the linked list. Just focus on that and see what can we do here in order to reverse it. Okay, we have to reverse it in such a way that then when I call recursion for the next k groups, I should be pointing exactly, the tail should be pointing exactly to the new head of the other reverse linked list. So that is the task, that is the additional task that we have to do is in terms of if we understand simple reversal of a linked list. Got it? So let's have a look. Let me just, I'll just point it out. So right now your current is pointing to head of your linked list. Got it? Your previous is pointing to null and your next is pointing to null. So the next thing that I'm going to do is, first of all, I need to get the track of the next link of this current. So I'll make sure, so while, now you see, while what? While your current is not equal to null and k is, and count, we are taking an additional pointer int count starting from 0, so that I can know that I have reached k nodes and I can stop there and call recursion after that. And your count, since I'm starting it from 0, is less than k. Okay, so you see this, while current is not equal to null and count is less than k. Got it? So while I'm doing so, what I have to do basically, make your next pointer point to current dot next. Why am I doing so? Because I have to reverse this link. So when I will reverse this link, actually I'll be pointing 3 with the previous node I just got. So this link will be killed. Now I want to do the same thing. I have to do the same reversal for this simple reversal. So I should have some node pointing to this node. This is the reason that now next is pointing to this node. Got it? Okay, so I have already done this thing. Next is pointing to current dot next. This is your first step. The second step that I am doing is that your cur dot next should be pointing to previous. Understood? Now what is the next thing? Next step is you have to also update the pointer so that you can do the same thing for the next node. Now this is how your list is looking like somehow, right? It is looking like this. So first of all, move your, let me take, which one can I take? This doesn't work. Give me a second. It is working. So this current, now this is how your list is going to look like. In the third step, what I'm going to do, make your current point to the next node. Basically current will be pointing to next node. Update your current becomes equal to next. Fine. And your, before that, your previous points to current, right? Your update your previous becomes current and your current becomes next, right? Now let's see how it is going to look like. So what I did in third step, if you see, previous, just this, I have to erase it only. So this previous from here moves to this step. Now previous is pointing to current from third step, and from your fourth step, what I can see is that current is pointing to next. So this current, it was okay, sorry. So this current has moved to next pointer. Now if you see, if you go to the while loop again, current is not equal to null still. Count is also in your fifth step, also increment the count, right? Now your count from 0 has become, here I am updating my count, it was 0, now it becomes 1. Okay, and what is the scenario? Now you see your current is pointing to 2, it is not equal to null. So first thing, obviously count is less than k. Next is pointing to current dot next. The current dot next is here. So let me bring my next pointer. Sorry guys, I thought of using this feature of this, but it's not working with the good pace. Okay, next comes here. This is where your next is pointing to. Now next step is current dot next is previous. So this is pointing to 2 is pointing to 3. You got it? This is how reversal is happening. So previous was null, so basically this is pointing to null. Okay, and the next step from third step is previous has come at current, current has moved to next, and count has become equal to 2. You got it? Fine. Again your while loop goes, current is not equal to null for sure, count is less than k, that is true. Now again do the same thing, next is pointing to, so basically this bond has been broken. Now current is not here, previous is not here, this is how it is looking like. Now what? Next is equal to current dot next, so this next moves to 6, right? Let me erase it and write next. So this next is at 6. Okay, fine. And now current dot next is pointing to previous, previous is here, current dot next is pointing to previous, previous comes at position of current, current goes at position of next. Okay, so next is removed, next is there, but current is pointing to next. Okay, fine, right? This is how it is looking like right now. Now what? Obviously this bond must have been broken by now, and your count has been incremented to 3. Fine, let's go to the loop again. Count is less than k. No, k was equal to 3 and count has become equal to 3, which tells me that I have already reversed one part of a linked list of size k. What do you see here? So your previous is pointing to the head of this newly reversed linked list. Okay, and right, fine. Okay, what next? What next? Now let's do one thing. This is your while part. Now what have we done? We have to repeat the same procedure for the next k groups of linked list. So let's say if this was your, this actually function started from here. Let me write recurse. For example, this is your recurse function, which is taking a node initially pointing to head, for example. Okay, not for example, that is the case. If you see, this is how it is. Obviously it is taking int k, we will pass it, no worries, nothing to worry about. What is the next case? That what you have to take care is that, see guys, everyone, in this reverse function which we are calling recursively, I have to return what? I have to return the newly found tail, right? So sorry, newly found head. So the newly found head of this linked list which I did was previous, right? So I have to make sure actually this has from 1 to 3, it has become 3 2 1. Am I right? What is wrong here? What mistake did I make? 2 is pointing to, sorry guys, so my dry run, the dry run I did it on the wrong linked list. So my bad. I hope you understood the dry run, but the whole thing was, for example, this was your given linked list 3, let's assume this was your given linked list 3 2 1 6 5 4 8 7. So ideally what should have happened now, I have found a linked list which looks like this. It has been reversed, so after reversal it is looking like this. 1 is pointing to 2, 2 is pointing to 3. That's what it is happening, 1 2 3. Now the next thing is that whenever I reverse the similar for the next k groups, I should be getting this 3 should be pointing to 4, then 5, then 6. So for that what I am trying to do is, see, if next is not equal to null, so we also when we took this previous current, I have taken previous current, previous I have taken, current I have taken, next I have taken. I'll just recheck if it is matching with what we have done. So this next, okay, this was your next iteration. So your next was here basically 1 2 3. Node dot next must be pointing to, I'll just show you this part. Have a look. See what are we doing here. let's see. Next equal current dot next, cur dot next equal prev is pointing to cur is pointing to next, count plus plus. This part you have understood. Now the next thing that we are doing is, now ideally your next, after this one iteration we have already moved it, your next must be pointing to which node. So if your next is not equal to null, which is true, your node here actually refers to head. So original head did not change, right? Your original head was this 3 when you were doing it. This was your original head now. So now this has become the new tail. So if your next is not equal to null, your node dot next, that means your head dot next, if the next part is, if your next is not equal to null. So what we are doing is, originally where was head? Your original head was head, which has now become tail for the reversed part of your linked list, right? So node, which is your head, actually we were referring to head dot next should be pointing to the new head of the another reversed linked list, right? So for that I am making a call to my recursion function, which is named reverse, or I'll name recurse, REVE, okay, reverse function, let's say. And what am I passing to it? See what I have to return. Now my next must be pointing to, see, you see where is my next? I have to reverse this linked list of size 3, in which your, let's say this is a new linked list, so the head is pointing to next. So the head that you are passing actually is your next node, and k is as it is, okay, int k. So this is being passed. So what you are doing, this was the previous head dot next is pointing to this reverse function, which will ideally reverse this 654, and it will come as 456. So this was your head dot next will be pointing to what? So you have to understand what we are actually returning from the recursion function. So we are actually returning, you see where is previous pointing to. Now if you observe that previous was present here, okay. So on reversal, if this was your function, okay, if this was your function on reversal, I got something like 1 2 3, right? 1 2 3. So you are returning the new head of your reversed linked list. So for the other one, your previous will be pointing to the new head of the reversed linked list. Got it? So that's what we are doing in this question. So this is typically about it. If you have any doubts, you guys can ask me. Let me just check here. Okay, fine, I'll explain you the question again. Shubham, have you understood? So now, because we have gone to the complete part of this question, if you still have doubts, let me know. I hope you have understood this. So this is the recursive approach. You can do it iteratively also. The difference between iterative and recursive, both are taking same time complexity. The only difference comes in the extra space, that stack space that this recursion uses. But this code is much neater and easier to understand. Iterative one becomes very long and little difficult to. It means the readability of code is better in recursion. That is the reason I've used it. So you can see that we are doing this, and we are crossing through each node at most once only. So maximum time complexity is O of n. So I hope you have understood this question. If you have any doubts why we are returning prev, anything, you can ask me. Fine. If you have no doubts, guys, I think you can have a look at the code. Fine. So this is about it. Okay, the base case condition, important part that we missed here. If your k is equal to 1, then reversing of that linked list will be the node itself, or if your node is equal to null, or maybe node dot next is also equal to null, return node means the head. That's all. Fine. Okay, good to know, Shubham. Fine then. So shall we wrap it up? Have you all understood this question now? It was a good question. It gives a very clear understanding of playing with the links and nodes and keeping tracks of whatever links you want by taking some pointers here of type node. That's all. Fine, everyone. Then let's wrap it up. Thank you, everyone. Bye bye and take care.